Hey everyone, it's Miss Witten here to talk with you a little bit about area. So, our first question, what is area? Area is the amount of space inside of a closed space, which usually with what we're dealing with is shapes. It'll be within a closed shape. But in real life, this could be inside of a wall. You could see how much paint you need to fill up an entire wall. If you were planting a garden, you could figure out the amount of soil that you needed inside of your planter. Things like that are real life applications of area that can be really helpful. Really important with area is that it's measured in square units. So units can be any unit of measurement. A unit of measurement can be inches, it can be centimeters, it can be feet, it can be yards, it can be miles, kilometers. Doesn't really matter as long as it's a unit of measurement. When there is no unit of measurement, you use units. So when we are squaring units, that means we're going to put this little squared symbol, this little 2, above whatever abbreviation. You can also write out squared, so squared feet, squared inches. You can write out the whole word square and put the word that's the unit of measurement. It doesn't matter as long as you're writing things in square units. So if it doesn't give you a unit of measurement, you can just write units squared. You can write squared units. You can write out the whole word square units. It doesn't matter as long as you make sure your final answer is in squared units. If it's given to you, so if a problem, we'll work on these in just a second, if a problem gives you inches or gives you feet or gives you centimeters or gives you a particular type of measurement, you do want to make sure that you are using that unit of measurement. But if they just give you no unit, then you use squared units. So how do we find area? There's a few different strategies that you can use, so I'm going to walk you through those. The first one is counting square units. Now you can only count square units if they give you a grid or if a square or a shape is drawn on grid paper with no overlapping squares. We cannot count square units if they just give us a blank shape, because we cannot draw our own units because we're not really sure if the drawing is to scale or what they're doing. So they have to give you a shape that looks like this in order to count the square units. Again, if they just gave you a square with some measurements on it, you can't make your own square units, right? We have to, when we're counting square units, be given a shape like this. So since we know that that area is the amount of space inside of a closed shape, this is a closed shape, so what we need to do is we need to count how many squares there are inside of the shape. So this one we have 1, 2, 3, 4, 5, 6, 7, 8. So our final answer is going to be 8 squared units. All right, again, we can count these squares, right? Because it's already given to us on graph paper or on a grid. So we know we can count these square units. Also, we couldn't find the area with measurements necessarily because they don't give us any. So let's go ahead and count our squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So 30 square units. Now, I know some of you might be thinking, oh, Ms. Witten, that took forever for you to count all those. And you might also be thinking, this kind of looks like an array, right? So we can also use our multiplication skills that we worked on. And we can say, okay, this is 1, 2, 3, 4, 5 squares long. And 1, 2, 3, 4, 5, 6. Or 5 squares wide and 6 squares long. So we can also do, and this will take us to our next strategy, is 5 times 6 equals 30, again, squared units, which you can also write like that. So that takes us to our next strategy, which is using the formula for area. This is super duper important that area you multiply. You are multiplying the width, which remember width is how wide something is, and length is how tall something is. So you are going to be multiplying width times length. So let's try this one. First, let's identify our width. Our width is how wide something is, so we know it's 8 feet. We can do 8. And length is how tall something is, and this is 8 feet tall. Now, due to the commutative property, it's okay if you flip-flop these, right? Because if this rectangle was on its side, it would be the same amount of space inside. So now we do 8 times 5 to get 40. And instead of your final answer being 40 square units, it's given us this unit of measurement of feet. So you can do feet with our little 2, or you can also write out squared feet or SQ.FT, whatever way you want. All right, now this one, same thing. We are going to find the width because area equals width times length. So my width, so I'll write A equals 10. I know I'm going to multiply, really important that you remember to multiply for area, times length, which is 3. And what is our unit of measurement here? It is inches. So I know my answer is going to be in square inches, and I know 10 times 3 is 30. So A for area equals 30 inches squared, or squared inches. Now I also want to take a second and explain something about congruent sides. So if you remember from when we were in class, congruent means that the two sides are equal to each other. What that means is that this side and this side are equal or congruent. So that means that this side is also going to be 10 inches. And same thing with our length. This side and this side are going to be congruent. So this side is also going to be 3 inches. This doesn't really come into play as much in area until we get to missing sides, but it is really important for when we get to perimeter and when we get to this next problem. So 7 feet on one side, 7 feet on other side. So same thing, identify area equals width times length. So my width is 7 feet. My length, how tall something is 7 feet. I know I'm going to multiply the two. And what have they given us here as our unit of measurement? They've given us feet. So I know I'm going to have some kind of squared feet. 7 times 7, 49. This time I'm going to decide to write it a little differently. Square feet, but still all the same. So you guys may already be 2 steps ahead of me and already know what shape I'm talking about here, but just know that this is a square. So sometimes what they'll do is they won't give you this other side, right? But they'll kind of show you this square-like figure and they'll only give you one side. And that's because for a square, all sides are congruent, right? All sides are equal to each other. So each and every side on this is going to be 7 feet. So onto those missing sides that I was talking about. Sometimes you'll see they'll give you a shape, a closed shape, so we know we can definitely find the area of it. And they'll give you the area, and then they'll give you either the width or the length. And you have to decide which one they've given you and which one you need to solve for. So, for example, this shape they've given us, it's a closed rectangle, and they gave us the area. See how our area is in square feet? So if I know area equals width times length, I can just plug in the A for area is 18. So did they give me the width or did they give me the length here? They gave me the width, right? Because it's 6 feet wide. So I can put a 6 here and then times L because we don't know L, right? That's what we're trying to solve for. We are trying to figure out what is the length of this rectangle. So what is the opposite of multiplication? It's division, right? So we can use our missing numbers, our unknown numbers, our fact families. We can use all that knowledge to apply here for our missing sides. So we can kind of just change some things around, right? I can do 18 divided by 6 equals L. And I can solve, right? I can do 18 divided by 6. So this would mean that L would equal 3, because 18 divided by 6 is equal to 3. So my answer is going to be 3 feet. Now notice I did not put square feet, right? Because square feet is only the answer to our area. We only use the individual unit of measurement, just like how they have it here and just how it's kind of fill in the blank there. You only use feet here. And a good way to check to make sure that you have done this right, that you did your math right, and that everything shakes out, you can do area equals width times length. I can say, okay, 18 equals 6 times 3. Check, that's correct. We can move on. Okay, so area equals 36 square inches. So our unit of measurement here is inches. So I know my answer is going to be something inches. So A equals width times length. Area equals width times length. I have my area. And do I have my width or do I have my length? Width, right? It doesn't really matter. Even if you had your length and you didn't have your width, you could do this exactly the same. So your width is 6 times L. So again, I can do 36 divided by 6 to get my length. And don't get tripped up because there's an L there. Even if this looked like this, which I know sometimes they like to use shapes, same thing, right? Even if I use a triangle, a smiley face, same thing as an L. That's just your unknown number. So 36 divided by 6 equals L. Length is going to equal 6 inches. Remember, not squared inches because your area is squared. So let's double check that we did it right. If area equals width times length, 36 should equal 6 times 6, which it does. You might again be 2 steps ahead of me and already be saying, Ms. Witten, this is totally a square, right? Then you would absolutely be correct. So all sides are going to equal 6, which makes this a square. So that was a super quick overview of area and some missing sides. Please let us know if you have any questions. Just the main thing to remember with area is that we're multiplying length times width, and from there you guys will do great. Happy learning!